Hello everybody, this is Joseph. So welcome to video number 4 for Securing Windows series. And in this video we're going to be talking about Secure Boot. So it has to be enabled on Windows 11 systems. So let's take a look at the STIG setting first. And as you see here, this is the Windows 11 STIG for this item, which is Secure Boot must be enabled on Windows 11 systems. The discussion says Secure Boot is a standard that ensures systems boot only to a trusted operating system. Secure Boot is required to support additional security features in Windows 11, including virtual-based security and credential guard. If Security Boot is turned off, these security features will not function. So let's look at the check text. Verify the system firmware is configured for Secure Boot. So when we talk about firmware, we're really talking about the BIOS. We'll get in that in a second. And there's a note here that says for virtual desktop implementations where the virtual desktop instance is deleted or refreshed upon log off, this is NA. So basically what that means is that if you're running a VDI and when you log off your VDI, the operating system goes away. Your resources are freed up, and then when you go to log back in, you're presented with a brand new virtual machine. So, but we're not doing that in this case. This is my home machine, or this could be your business machine where you're not doing VDI. So let's move on. So it says run system information. So I'm going to click start on my Windows machine, run system information, and it pops up. Go ahead and click that, and it expands quite a bit here. Let me shrink this a little bit. So we're in system summary, and going down here we see secure boot state is on. So what if it's off? So that's why, we're going to walk through this real quick. However, there's one thing I have to say. I can't reboot my machine and record my BIOS. So we're going to have to do a little bit of talking here, and I don't like to really do that. I want to show you hands-on, but right now I have no other way to do that. So the best thing we can do is let's assume this is off. And what you need to do is go online or go to your box where you got your motherboard and find your motherboard manual. So let's do that real quick. So I'm browsing the internet. I go to Gigabyte, and this is the Gigabyte website since I have a Gigabyte motherboard, and this is my model. I have version 1.3, and I'm going to go to the manual section, or this could be Intel, this could be HP. I mean, whatever your motherboard is, go to manual, open up your English if you speak English, and they got quite a bit of others here. Open that up, and this is what you get. So we're talking about Secure Boot. So let's do a search for Secure Boot, and I'm not going to go straight into. I'm pretending as if I'm somebody who's trying to find specific things. So this is what I would do. So I'm going to click Control F. I'm going to type in Secure Boot, and it should take me to a section that has Secure Boot. If it doesn't, then more than likely your motherboard doesn't have Secure Boot capabilities. It should if you bought it in the past couple of years. Your entire machine, your motherboard would have it. So it says allows you to enable or disable Secure Boot. So there is a feature on the motherboard, on my motherboard, that allows me to enable or disable Secure Boot. It's only configurable when CSM support is set to disabled. Okay, well, what's CSM support? Well, let's go ahead and look up CSM support. Alright, found it once, it's 5 times. Alright, CSM support. It's another function or feature on my motherboard. So it says enables or disables the UEFI CSM compatibility support module to support a legacy PC boot process. So if you're using a legacy operating system, right, such as XP, ME, and I'm not an expert in that part, but all I know is it's not Windows 10, it's not Windows 11. So if you're running something older than that, you can consider it legacy. And so CSM would support that. We're not running legacy. We're running Windows 11 or Windows 10. So we are going to disable UEFI CSM, and we're going to support only UEFI BIOS, right? Okay, so if it says when you go on your motherboard and if it's enabled, you need to disable it. And this will allow Secure Boot to be configured. So before we get into that, right? So let's look at my motherboard, and I'm pretending I rebooted my machine. I hit the delete button because that's what gets me in my BIOS. Your motherboard might have something different. Again, if your motherboard manual will tell you everything you need to know about how to move around, what to do, how to do it. So if you don't know if it's F2, F11, F9, F10, whatever, use your motherboard document and it will tell you exactly what button to press to get into your BIOS. So let's imagine that I restarted my machine and I hit the delete button. Trying to get this, there we go. I hit the delete button and it brought me to this page, and this is exactly what it would bring to if I were to do this, because I just did it a few minutes ago. So I'm going to find where it says secure boot, and again, your motherboard manual will tell you exactly where to go to find it, or you just browse around. So if I was in here and I was on this boot screen, which would be where my secure boot's supposed to be, and as you can see it's not, that's okay. It just means it's not shown because I imagine something else is enabled and we're going to disable that. So let's say I have my down button and I'm pressing my down button and it goes through and I come to CSM support. And I'm going here because my secure boot in my operating system says not enabled or off. Well, I want to enable it, and that's why I'm here. So I would go to CSM support, and again, CSM support is for legacy operating systems. We're not using legacy, we're using new stuff, right? So I'm going to highlight the CSM option here. I'm going to hit enter and I'm going to hit disable. And then when I do that and hit OK, when I do that, it's going to come out and show me this screen again. However, further down here, it's going to show me the secure boot option. And so I'm going to use my down arrow and I'm going to highlight the secure boot option, or wherever it's at according to your motherboard. I'm going to hit enter because more than likely it's going to be disabled by default as soon as you see it. I'm going to hit enter and I'm going to change it to enabled. And then when I do that, it's going to say, okay, secure boot's enabled. Now I'm going to go off on a side here because there's a couple little tricks and troubleshooting I need to point out. Now, you're going to have a couple other things in order to enable secure boot on your system. The first thing you have to have is a TPM. If you don't have a trusted platform module, you're not going to be able to enable secure boot. So in your BIOS, you can also find your TPM setting, and either you've added a TPM, and I think my other video explained this, is either video number 3 or 2 about adding TPMs. Your TPM could be part of your processor, so you may not have to buy an external TPM module like I did from my computer. And if that's the case, well, how do you enable that? Well, let's go up here and type TPM, and that's where I installed my TPM on my motherboard. A little tiny thing costs 20 bucks, but like I said, it could be on your processor, and it would explain that to you inside of your motherboard manual. So I'm looking for the words TPM here. Okay, so right now, alright, so right here, right? So if you have an AMD CPU, it's possible that you already have a trusted platform module. So I had to use this one, enables or disables TPM, because I installed mine. If I had an AM CPU that had a trusted platform module built into it, then I would just have to enable this setting that would be shown. And like I said, its default shows as disabled. So you would have to manually go in here and enable TPM, and in addition to enabling secure boot. And then now what you would do is you save and exit. Make sure you save your changes and exit. But I want to warn you, anytime you make changes in your BIOS, you have the chance, if you make the wrong changes, to brick your system or not allow your operating system to boot. So whatever you've done, go back into your BIOS and undo, and then your chances of getting back in your operating system are good. But I've done this a million times on mine, so I back and forth. So I'm no matter what changes I make with the TPM, it's not going to affect my ability to log in. So again, you at this time make sure you have your TPM, whether it's a processor integrated TPM or a external device you have to plug in, and choose the appropriate one that you have. So now I'm going to save and exit, and I'm going to let boot in my regular operating system. So we can get rid of this screen here, and now I'm back into my regular operating system. As soon as I go into this summary, it's going to say secure boot is on. And I'm going to go back into the device. So if I go in here, right, say, okay, well, great. Let me type in secure boot on my Windows. When I type in the word secure, it automatically brings up device security. And again, we're going a little beyond what was said, and about just going into the one setting, because there's so many nuances to this, and it requires a little bit of learning and a little bit of research depending on your motherboard type and the troubleshooting you may have. But when I typed in secure boot, right, it brought me to this screen. And so here's my secure boot setting. If I didn't have, or if this secure boot was off because it was off in my BIOS, I would not see this option. It would go away. But since it detected the firmware, I made the setting enabled in the BIOS, I booted up my machine and it recognized it. Now the option is here. So there's nothing you can really do other than enable it. It just shows that it's there. Now what I'm going to do is I'm going to go ahead and close this, and again, that's how you would check if it's on or off. And now I am compliant with this configuration, this security configuration on my computer. And now let's move on to the Risk Management Framework Control section. And down here it says CCI 002421. The information system implements cryptographic mechanisms to prevent unauthorized disclosure of information and or detect changes of information during transmission, unless otherwise protected by organization-defined alternative physical safeguards. This is NIST RMF Risk Management Framework Control SC8. So if you were to go in and look at SC8, and I have a PowerPoint slide here, we're going to go down here and we're going to look at the RMF publication, which has all 853, which has all the risk management framework controls, whether they're technical, operational, or manual. Right now we're looking at a technical one. This is the SC family. So we go SC-1, Systems and Communication Protection. Again, we're protecting our system, we're protecting the communications. And there is, and it's not here, so give me a second. So let's find out where we can get this. This is good stuff. If I go in here and type in 853 Rev 4, it should bring up the document. You can do Rev 5 if you want. Rev 5's out, right? It was out already. I'm going to click this to open this link, and I'm going to do a search for SC-8. Okay, as soon as this pops up. And Control F, SC-8. Alright, so we're going to do a couple clicks here to get the SC-8. They don't really make this easy. I'm going to tell you that right now. But I'm sure you guys would be doing the exact same thing I'm doing. So SC8, right? And let's check that again. SC8, and if it's in parentheses like this, it's enhancement. So this is enhancement 1. We're going to go down here to SC8. This is the original control, right? The information system protects the blank of transmitted information. So when we're talking about this, right, and we're talking, okay, transmitted information. Well, we're not really transmitting anything in our BIOS. This is the closest thing we have to the ability to encrypt our boot process, right? So they assign this control to this and say, well, if you're going to do secure boot, this is the closest thing we have due to integrity of the boot process and the encrypted boot process. So enhancement 1 says transmission, confidentiality, and integrity, cryptographic or alternate physical protection. Okay, we're doing some physical protection here by adding a device that has the ability to encrypt and our boot process. So let's read this. It says the information system implements cryptographic mechanisms to prevent, so it says select one or more of these, to prevent unauthorized disclosure of information, or to detect changes to information. So we're trying to detect changes of information specific to this, because if it detects a problem with the boot process, it's going to let you know. And the during transmission, yes, it's going to let you know, and it's going to give you an error. right? So the purpose of this TPM module is to prevent these things from happening and to utilize the default encrypted 100%. This is the right boot process, without any external factors. During transmission, so again, the transmission in this sense is the boot process working amongst the parts to validate that integrity is maintained while it boots. So it's not the perfect control to use for this, but I think it's the most appropriate because there's nothing else to really use. And then you go down here, right, when you're reading these controls in RMF, you look at the supplemental guidance, right? It's very important to understand how this works. And so it says encrypting information for transmission, protection from unauthorized disclosure and modification. Again, we're not talking about the disclosure here. When we're talking about an encrypted boot process, we're talking about modification, right? The cryptographic mechanisms that are built into the TPM modules, right? The hashes and all that, to protect information integrity, which include digital signatures and checksums, right? And then that's about it for this. So we've said things here which are not very clear. We're trying to make leaps to these controls based on this change that we're making. But if you have time, I would definitely suggest that you go into Microsoft and read the various elements of what Secure Boot is, because it's not just a simple, oh, we have this device, it protects you. Okay, great. Well, not only that, it's all about digital signatures. There's a database built into your Secure Boot process that has keys. There's all kinds of things, and actually, let's just take a mental look. So if we go in here and type in Secure Boot, let's do Microsoft. Let's see what pops up. Okay, sure. Let's go to this one right here, right? And this is Microsoft Learn. So you can read. There's a lot of stuff here, right? I would definitely read it. There's some requirements that you have to have. I have Windows Pro on my machine. And then secure the Windows boot process. I mean, there's rabbit holes you can go down to, right? But it starts talking about how it boots, the trusted boot process, and right here the bootloader was signed. Okay, great. And you can go on and on. But not only that, right? When you're talking about Secure Boot and the trusted boot process, but if you go in here and type in Secure Boot for Red Hat, they have another section that you can look at. And it gets pretty detailed as well. So what is UEFI Secure Boot and how does it work? And so this is what Red Hat has written for theirs. And there's all these steps it has to go to validate the integrity of the boot process. So yeah, I mean, even though it's a simple setting that I can do on my home machine and most small businesses, when you start getting into big time enterprise corporate stuff, sometimes you have things that don't allow signed drivers. There's always exceptions as to why you have legacy stuff, and doing the Secure Boot process may disallow those applications and various things from running. So again, it's easy for homes and very small businesses to do these changes, but when you're in an enterprise environment, you have to do security requirements, you got to do tests, evaluations in order to do that. So I know this video was a little long. Secure Boot requires the BIOS. It's not always fun to mess with the BIOS, but hopefully I gave you some steps on how to do that. But again, your motherboard manual is your friend. Definitely read it, and you can find out all kinds of other things about your BIOS. And we may be coming back to the BIOS or the motherboard manual later in other video series and other videos, because it requires us to change BIOS settings. So I hope you enjoyed the video. Again, this is my information of who I am, and if you have any problems, just comment. I'll be more than happy to answer any questions, provide you some guidance, and or admit that I'm wrong. So whatever works. All right, have a good day.